Audio Jungle. Audio Jungle.
Hello everyone. So now for the today's session, uh, we'll have a thrust required, right? So we'll discuss about the thrust required. Thrust required for for level and unaccelerated flight. And unaccelerated means what? Steady flight. Okay, steady flight. So we'll calculate thrust required. So this analysis we can check what is the steady and level flight. What is the steady and level flight? First, steady and level flight is what? Suppose this is the aircraft. Okay. Fine. For this aircraft, check because it is the level flight and definitely it is aircraft is what moving in this way with velocity v infinity. So definitely whatever the air air will be coming like this. Okay, yes or no? Better I will remove this and will show this is the air. Okay, this is the air coming towards the aircraft. So as we know, if the air coming towards the aircraft with v infinity, the same velocity will be for the aircraft. Yes or no? Now this is what free stream. Fine. If you check the different type of forces for the steady level, so definitely weight will be acting normally downwards, normal to the motion of the aircraft or normal to the motion of the free stream velocity. Perpendicular to the free stream velocity will be the lift force, and it is moving in forward direction. So that force which is responsible for the forward motion will be thrust, and it will be opposed by the one force which is called drag. So for the steady and level flight, what will get, that is nothing but lift is equal to weight and thrust is equal to drag. Yes or no? This is the one thing for the steady and level flight. Now if you go for the calculation of the thrust required, so one small manipulation you have to do. What is that? It is nothing but thrust required, or simply it is written as thrust, is equal to drag for the steady level, and because weight is equal to lift, so that we can do one thing, we can multiply by weight and divide by weight. Yes or no? Now, so this thrust required will be what? Drag into that weight, you can write as weight as it is, and then you can write, instead of W you can write lift. Yes or no? Because just now for a steady level flight, lift is equal to weight or weight is equal to lift. We can write like that. So now here it is nothing but weight into 1 upon L by D. We can write this. This is nothing but what? Thrust required. What is L by D? L by D is nothing but half rho v square S into CL divided by half rho v square into S into CD. CL, CD lift coefficient and drag coefficient. We can write this for the constant angle of attack. Yes or no? So this value will be what? CL by CD. Okay. So here also we can write weight into 1 upon CL by CD. We can write this. So we have this thrust required. This is also so what is this? Thrust required is directly proportional to weight of aircraft. If it is light aircraft, thrust required will be less. If it is heavy aircraft, jumbo aircraft, thrust required will be more. Thrust required will be more, then you will have more powerful engine or number of engine you have to increase. For that reason, if you check very heavy aircraft, jumbo jet aircraft or heavy aircraft, so that engine, if you check two engine right wing, two engine will be on left wing, means four engines will be there. Why? Because it is very heavy aircraft. So thrust required is always directly proportional to weight of aircraft. Even if it is very small aircraft like fighter aircraft, engine aircraft weight is very less, so that time you will have only one engine. Yes or no? But my point, so thrust required will be directly proportional to weight of the aircraft, number one. Number two, thrust required is inversely proportional to L by D. What is L by D? L by D is nothing but aerodynamic efficiency. So it is inversely proportional to aerodynamic efficiency. If aerodynamic efficiency will be high, thrust required will be less. Okay, if aerodynamic efficiency is less, thrust required will be more. That's the mean of it. These two conclusion you need to remember. Okay, if they will ask in examination, then you can answer for 1 mark. All right, this is the one. Drag polar already I have explained in last session, so but in short I will explain again. Drag polar equation. What is the drag polar equation? Drag polar equation is what? It is the drag equation. What is the drag? Total drag. I must say total drag. What is the total drag? Total drag is nothing but it is called zero lift drag plus lift dependent drag. Zero lift drag plus lift dependent drag, also called as induced drag. So total D is equal to D naught, zero lift drag plus DI. Okay. You know what is the drag? It is half rho v square S into CD. What is D naught? Half rho v square S into CD naught, half rho v square S into CDI. If you keep this, so what you will get? CD is equal to CD naught plus CDI. Yes or no? CD is equal to CD naught plus CDI. All right. Now, what is this CD naught? zero zero lift drag coefficient. What is CDI? Induced drag coefficient. Yes or no? Zero lift drag coefficient and induced drag coefficient. All right. Now, this zero lift drag coefficient also, or D naught, which is nothing but zero lift drag. The zero lift drag also called as a parasite drag. What it is called? Parasite drag. Yes or no? Parasite drag. And the coefficient will be parasite drag coefficients. Okay. So this CD naught, I can write again. It is zero lift drag coefficient. Okay. Or it is called parasite drag coefficient, or it is also called profile drag coefficient. These are the different name. Okay. Profile drag coefficient or parasite drag coefficient or zero lift drag coefficient. Fine. Similarly, need to remember this. Similarly, CDI. CDI. What is the CDI? It is called lift dependent drag coefficient, or it is also called induced drag coefficient. That's the reason it is CDI, I for induced drag. Induced drag coefficient or trailing vertex drag coefficient. All right. So these are the terminology you need to remember. Now this CDI, mathematically it is given by the formula KCl square. What is the CDI? It is KCl square. Okay. What is the K? What is the K? So K is the basically constant. Sometimes it is called as a lip dependent drag coefficient factor. What it is called? Lip dependent drag coefficient factor, which is given K is equal to, mathematically it is given as 1 upon pi EAR. What is the K? 1 upon pi EAR. What is E? Is again, it is called Ostwald efficiency. Okay, what it is called? E is nothing but called as Ostwald efficiency. It is called Ostwald efficiency factor. Ostwald's efficiency factor. What is the AR? Aspect ratio. Okay. What is the aspect ratio? Aspect ratio is nothing but span square divided by wing planeform area. If span is B square, planeform area is S. What is the planeform area? It is S. Or sometimes it is denoted A, but here you can denote S because in formula of lift and drag you have seen half rho V square SCL. So S is what? Planeform area. Or sometimes it is also called weighted area. Okay. The Ostwald efficiency factor, generally it is less than 1 for elliptical wing. What is the elliptical wing? E is equal to 1. Always remember, for elliptical wing it is E is equal to 1. Okay. E is equal to 1 for elliptical wing. Fine. So like check for rectangular wing. For rectangular wing, see, this is the rectangular wing. Okay. This is B. This is C. C for chord. Okay, chord. Chord of the airfoil, you know that, right? Chord. So what is the planeform area? It is B into C. So what will be the aspect ratio? For rectangular wing, it is B square by S. Means B square divided by B into C means B by C. This is for the rectangular wing. All right. So hope you understood the basic analysis of the drag polar equation and all the variables available in drag polar equation. Now you understood that. All right. Fine. Now we have one analysis, okay, which is called as a like minimum drag condition, because if you check for the aircraft what should be the condition should be like minimum drag, because why, what is the drag is the resistance. Okay, if aircraft is what moving, then what is the resistance force for the motion? It is drag. If drag will be less, then resistance for the aircraft motion will be less. If resistance for the aircraft forward motion will be less, then obviously thrust required will be very less. Yes or no? So let me write, what is the drag? Drag is nothing but resistance force for the moving aircraft. Okay, if drag is less, then what is the drag? Thrust required. So thrust required will be less. If thrust required is less, okay, thrust required will be less, then fuel consumption for the engine will be less. Fuel consumption will be less. That then what will happen? Obviously you are saving the fuel, means you will get economical benefits. Yes or no? So that is what desired. Okay, what is the desired thing? That fuel consumption will be less. You want that. So for that reason you will always talk about the We will always talk about minimum drag condition. If the pilot would be knowing what is the minimum drag condition for the aircraft, so he or she will try to fly the aircraft at minimum drag condition, and when minimum drag condition will be there, then fuel consumption will be minimum. Fuel consumption will be minimum. It will give the economical benefits. Means that is the desired thing. Hope you understood. So now we are going to approach what is the minimum drag condition, and how we can uh, fly the aircraft so that we can achieve minimum drag condition. What should be the condition, what should be the criteria for minimum drag condition, that we have to find. Yes or no, that we have to find. So now check. We'll write minimum drag condition. Minimum drag condition, yes or no? Okay, we'll do this. So what is the drag? Drag is nothing but simple. We have half rho v square s into cd. Okay, this half rho v square s into what? Cd. Cd I told you, cd naught plus cdi. Yes or no? Right. Then it is, you just break it, half rho v square s cd naught plus half rho v square s into cdi. And what is the cdi? It is kcl square. Yes or no? kcl square. Now we know lift is equal to what? Half rho v square s into cl. What is the cl? Actually lift is equal to what? Weight. So we'll get 2w by rho s v square. So this cl value, okay, what cl we got? This cl value we have to keep here. Next slide. Huh? So what we have now? Drag. Check. So this drag is half rho v square s into cd naught plus half rho v square s into k. Yes or no? K cl square. What is the cl? 2w divided by rho s v square kcl square. So this is the kcl square. Yes or no? 2 na kcl square. We will find this. What will get? Half rho v square s cd naught plus half rho v square s k 4w square divided by rho square s square v to power 4. Yes or no? We will solve this. What will get? Half rho s cd naught, this is what, v square plus, check, 2 and 4 is 2 now. Check density, we have rho, and this is one density will be cancel out. S, one S will be cancel out. V square we have, V square will be cancel out. One V square will get because it is V to power 4. Now, what will get here? So we got 2 kW square divide by rho S 1 upon V to power 2. Yes or no? Check. This is the value we'll get here. Yes or no? It is nothing but 2 kW square divided by rho S. v to power 4. Now check. Very important point I'm just going to tell you. What is this first part? What is this first part? This first part, if you check, it comes from first part, which is nothing but CD naught. No? Check this part. This is what? Half rho v square S CD naught. What is the half rho v square S CD naught? Half rho v square S CD naught. See, this is nothing but D naught. What is the D naught? It is the parasite drag, or you can say it is profile drag. Yes or no? So I can say this is first part is nothing but parasite drag. Okay, this is what parasite drag, and this is nothing but obviously induced drag. Induced drag. Okay, so for the parasite drag, okay, for parasite drag, what we got, D is equal to half rho S CD naught into V square. Yes or no? Check. Half rho S CD naught into V square. That means drag directly proportional to V square, means velocity square. Yes or no? Should be very clear here. There should not be any kind of confusion. Fine. Now for induced drag. Check. Drag is equal to, we got here, if you remember, 2k W square. See, 2k W square by rho S. Means drag directly proportional to or inversely proportional to velocity square. Yes or no? For this, we'll draw the diagram. It will be more clear to us. No, because this is the first graphical representation. Graphically, if we'll understand, then we'll go for the mathematical point of view, right? Now, so we have to draw the plot. What is the plot? Plot we have drag versus velocity. Drag versus velocity, right? Now, so first we'll draw for the parasite drag. Okay, first we'll draw the parasite drag. So let me take this. Okay, parasite drag. What is the parasite drag? Check. Drag directly proportional to velocity square. It is just like a parabola. So just like parabola means like this. Huh? Yes or no? This is what, just like a parabola. This is drag directly proportional to velocity square, which is nothing but parasite drag. Parasite drag. Fine. What is the next? Next is the induced drag. What is the induced drag? Check. Drag inversely proportional to velocity square. Okay. So drag inversely proportional to velocity square means it will be like this is what? Drag is directly proportional to, sorry, drag is inversely proportional to velocity square, and this is what? Induced drag. If you check the resultant, okay, if you check the resultant of the plot, so where resultant will I see? This part is what? Decreasing, so here it is increasing. Similarly, this part is what? Increasing here, so this part is what? Decreasing. You got my point? Yes or no? So this plot, you can say A O B, C O D. So AOB, if it is continuously decreasing, and COD, if it is continuously increasing, so one part is what, like you can draw one line here, so it will be more clear. Check. Yes. So half the part where velocity is what increasing. See, half of the part here, velocity, you are getting velocity increasing, but drag is what? Decreasing. Is it possible? No. Generally, for the complete full, if you check total drag, so total drag will increase when velocity will increase. But here, in this case, now before this, I mean this side, if you check this AO is what? Velocity is what? Increasing, but drag is what? Decreasing. Yes or no? AO. For the AO, velocity is what? Increasing, but drag is what? Decreasing. Check. What about, I'm talking about AO. What about OD? Check OD. Still OD, in case OD, velocity is what? Increasing, but drag is also increasing. So this is the physically possible. I mean, if velocity will increase, drag will increase, total drag. That is true. So for that reason, this AO reason, nah, so two reason you got. What is that? One is AO, another is OD. So for that reason, AO reason is called as region of velocity instability. Okay, and OD region will be called as region of velocity stability. Why it is called stability? This is stable, and this is unstable, right? Why? Because if velocity will increase, then drag should increase. But AO in this region, velocity increasing, but drag is what? Decreasing, which is not good for the aircraft. So it is like unstable. So this type of instability called as region of velocity instability. Let me write region of velocity instability. And this side it is the region of velocity. Okay, velocity stability. That is correct. If velocity of the aircraft will increase, then drag will increase. That is true. It means it is stable. So OD will be the stable zone and AO will be unstable zone. Understood? So this is the plot, basically drag versus velocity. But where is the minimum drag condition? If you check where is the minimum drag and what is the total drag, so for that I need to draw another diagram. I mean the same diagram I have to draw, but in next slide. So here check. This is nothing but check here. So here easily you can understand where is the minimum drag condition. Okay. So this is what drag D, and this is what velocity D. Yes or no? Again the same thing we'll do. We have a parasite drag. So in parasite drag, it is drag directly proportional to velocity. So drag directly proportional to velocity square. And where is the this induced drag? So induced drag will be somewhat here. This is what induced drag. Okay, this is the induced drag, where drag is what inversely proportional to velocity square, and this is what parasite drag, where drag is directly proportional to velocity square. All right, drag is directly proportional to velocity square. Fine, velocity square, yes or no? Nice. So where is the resultant of this? Okay, so resultant will be somewhat here. This will be the resultant. Okay, if you draw properly, you will get like this. So in this case, if you check, this is the resultant of parasite and induced drag. Okay, so this will be what? This will be total drag. Total drag D, because this is the induced drag Di, this is the parasite drag D naught. So total drag will be what? D is equal to D naught plus Di. Yes or no? Fine. So this is the total drag. For this total drag, if you check what is the minimum point of this total drag, that minimum point where you are getting, check, this is the minimum drag D min, and where it is happening is velocity will be velocity at minimum drag. Understood? So if you check where minimum drag you will achieve, where the two plots, I mean parasite drag line and induced drag line, where it is crossing to each other. So at, from the plot you got at minimum drag, where it is happening, you can say this is point O, where it is crossing to each other. So D meaning D min occurring at point O. Yes or no? At point O. And at point O, that two lines, basically parasite drag line and induced drag line, are crossing to each other. So at point O, can you say, because two lines are crossing like C. So at this point where it is crossing to each other, that magnitude of that two will be same or not? So at O, can you say, at point O, can you say parasite drag? Wait. Yes. Can you say here at point O? This is the point O. Best. At point O, parasite drag equal to induced drag. Yes, you can say at point O, where that two lines are crossing to each other, so that you can say both values are same at that point O. So where D min occurs, D means occur at condition. What is the condition? Where D naught is equal to Di. This is the graphical representation. Understood? For our understanding. But with the help of this, we cannot solve the gate problem. How we can solve gate problem? By the analytical way. This was the graphical analysis. Okay, minimum drag occurs when the parasite drag is equal to induced drag. What conclusion you got? Conclusion. What conclusion? Graphically, we have seen what we have seen. We have seen that minimum drag, okay, occurs. Minimum drag occurs when the profile drag or profile drag or parasite drag is equal to induced drag. Means parasite drag is what? D naught is equal to induced drag, or in terms of coefficient CD naught is equal to CDI, or is equal to, what is CDI? It is KCl square. This is what? This is the gate question. This is the gate question. So at D mean means at minimum drag. At minimum drag, what is that condition? D naught is equal to DI, or CD naught is equal to CDI, or is equal to KCl square. Graphically we got this. Now check this. This is the graph. Fine. Now we'll go by the analytical way. So again, it is very simple, and that is important because question will be asked to you based on an analytical analysis, not graphical. Graphical is just for understanding. Okay, or they can give the graph and they can ask where is the D min and what is the condition for the D min. That they can ask, no problem. If they will ask, then you can answer it. Okay, fine. Now minimum drag analytical. So how to get that? Simple one only. Minimum drag condition. All right. So little bit manipulation. What is the manipulation? Drag is equal to, we know that we can write drag is equal to drag, but if you multiply by, what you can multiply? W by W. Okay, or you can write drag into W, you can write W, but this W you can write L, that is lift, because lift is equal to width, that you know. So this is the small manipulation. Yes or no? Now this is nothing but W into D by L. All right. So this D by L also you can write. I explained in previous slides. What D by L you can write? You can write CD by CL. That also already I have explained. No need to explain again. Then it is W weight into CD. CD is nothing but CD naught plus KCl square. That is drag polar equation. That also I have explained. No need to again. No need to give the explanation again because already just now I have explained. Okay. CD naught plus KCl square. Weight is what? Constant. So if I say I need D min, I need D min. Okay, then what we will do? Because weight is constant, we cannot do anything. So for the D min, what value will be minimum? This CD naught plus KCl square by CL. This should be minimum. Yes or no? This should be minimum for minimum D min. For minimum drag, this value should be minimum bracket value, because weight is constant, so we cannot touch the weight. Only CD naught plus KCl square by CL. We can say if this bracket value will be minimum, then we will get drag minimum. All right, so here we can write what we can write for drag, for drag minimum. Okay, CD naught plus KCL square by CL, this bracket value. Okay, bracket value should be minimum, that we have to write, should be minimum. Understood? Now again, CD naught plus KCL square by CL. If I'm saying this is minimum, then what is the mean of it? What is the mean of it? Bracket. No? Don't think this is mod. If I'm saying this is minimum, then what you will do? You have to differentiate it and make it equal to 0. That is the one thing. I mean, slope you have to show, slope will be 0. Yes or no? That is the mean. Okay. So here if you check, suppose this is the one function y axis and this is x axis, and for the function you are getting plot like this. Huh? So if you check at the maximum, this is the maximum and this is what? Minimum. So at maximum and minimum, what is the slope? At maximum and minimum point, slope will be what? 0. Yes or no? For that reason, if you are going to maximize or if you are going to minimize, that time you just take the slope. Slope is what? What is the slope here? Okay. Slope is for y and x axis, slope is nothing but dy by dx. Yes or no? This is the slope. So slope will be 0. And if you make slope equal to 0, it means that point will be maximum or minimum. Anything can happen. Maximum or minimum. Here you are going to minimize this. So this bracket value should be minimum. So to minimize this bracket value, you have to take the slope. Slope means that differentiation, and differentiation with respect to what? Variable. What is the variable? CL lift coefficient. Because CD naught is constant, K is constant. So CL is variable. So you have to take differentiation with respect to CL of this bracket. Okay, and make it equal to 0. If you do that, then you will say this is the condition for the minimize the function or minimize the bracket here. Yes or no? Now take this. So what you will get? It is like u by v form. So it is CL square. Okay, it is CL square. Then denominator differentiation. Then you have to take differentiation of the numerator. Okay, so write this. CD naught differentiation will be 0 plus differentiation of this 2k CL minus. You have to write this bracket CD naught KCL square, and CL differentiation in denominator it will be 1 because it is differentiating with respect to CL only. So this value you will get. Yes or no? If you solve, then what you will get? You will get 2k CL square. Check the bracket. 2k CL square first bracket minus CD naught minus KCL square equal to denominator cross multiplication. So denominator will be 0 now. I mean it will go and multiply with 0. So it will be 0, right? What you got? 2 KCL square minus KCL square. It is nothing but KCL square minus CD naught is equal to 0. What you got? You can say CD naught is equal to KCL. What is the KCL square? It is CDI. Means what? What is the CD naught? Parasite drag. What is the CDI? It is parasite drag coefficient. Better. and it is induced drag coefficient. We have seen, right, KCl square is equal to CDI. So what is the condition where you achieve, what is the conclusion? Conclusion is at minimum drag, at minimum drag, what you got? Parasite drag is equal to parasite drag coefficient is equal to induced drag coefficient, or what you can say, or you can say parasite drag is equal to induced drag. Yes or no? This is the same thing you have achieved here on graphical way also. See, this was the graphical. D naught is equal to Di, or CD naught is equal to CDI, or is equal to KCl square. The same thing you have achieved. Huh? This is what analytical. Huh? So what you got? D naught is equal to Di at D mean D naught is equal to Di, or CD naught is equal to CDI. This is the conclusion you got both way. Okay. Because why I have shown you graphical point of view also, that graphical point of view explanation was required. Why? So the student can relate it graphically. Yes or no? Analytically, I mean mathematically, if I will derive, you will get the result, but you cannot relate basically. But graphically you have related, like, okay, when that parasite drag and induced drag are crossing to each other, then only will get minimum drag, no? And you have seen the plot and you have decided, okay, this is the minimum drag. The same thing, if you go in analytical way, then you mathematically you will perform, and then you will get this result. Understood? But that story is what not ended here. What now you have, what get question they are asking, that is the one type of question, like what is the condition for the minimum drag. So you have to answer where the parasite drag becomes induced drag, or parasite drag equal to induced drag, then minimum drag condition can be achieved. But under this minimum condition, what result you got, that question will be asked to you in examination. So you have to write what you have to write: at minimum drag condition, at minimum drag condition, okay, or you can write under, you can write under the minimum drag condition, under the minimum drag condition, under the minimum drag condition. What is that? You have to write first, which is nothing but lift coefficients. One by one we have to do. Number one, lift coefficient at minimum drag. So that will be denoted by lift coefficient CL, but it is minimum drag, so you have to write MD. MD for minimum drag. So CLMD means lift coefficient at minimum drag. How to get this? Very simple. What result you got? CD naught is equal to KCl square. So this CL is not normal CL. This CL is the minimum drag CL. Yes or no? So here it will be CLMD. What you will have? CD naught by K. So this CLMD is very powerful formula, okay, and you have to use this for the numerical point of view. You need to remember this. This is the CLMD, which is called lift coefficient at minimum drag. Okay. Similarly, we have to write point number 2. What is point number 2? Drag coefficient at minimum drag condition. Yes or no? Right. How to achieve this? You know, CD naught is equal to CDI is equal to KCL square. This is the minimum drag condition. If you write drag polar, CD is equal to what? CD naught plus CDI. Yes? Or you can say CD naught plus KCL square, meaning same. So what is the CD? Now CD, it is CDMD, minimum drag. So CD naught plus what is the CDI check? It is CD naught again. So we have 2 CD naught. So basically minimum drag coefficient CDMD will be 2 times of the CD naught. Number 2. Okay. Similarly, third one, we have velocity at minimum drag condition. How to get this velocity? Simple formula we need to remember. L is equal to, for steady level flight, L is equal to W is equal to half rho V square S into CL. Right? Now we are writing minimum drag, so this CL will be minimum drag, CL. And this velocity, if you calculate, here also you can write minimum drag. So this VMD will be what? 2W divided by rho S VLMD. Yes or no? Huh? All right. Rho S CLMD, that you can write. Again, if you want to break CLMD, you can break. It's your choice. Okay. It's your choice. If you want, you can write like this. 2W divided by rho S to whole power 1 by 2. And CLMD will be what? CD naught by K. So K will go in numerator divided by CD naught. But it is CD naught by K was in root. So double root you will have. So it will be 1 by 4. You can check by your own. You may get that. This is the VMD. Yes or no? This is the VMD. Velocity at, I will suggest don't remember the formula. At least you should know how to calculate that. CLMD you have to calculate and keep here in the formula, and directly you can get VMD. Don't remember the formula always. Okay, here I am explaining so that you can understand. But the formula I will suggest don't remember all formula. Huh? Right. Then last we have, what is the last? Aerodynamic efficiency. What is the aerodynamic efficiency? Last 4 number. Aerodynamic efficiency at minimum drag condition. What is the aerodynamic efficiency at minimum drag? It is EMD. Aerodynamic efficiency is what denoted by E. What is the formula? L by D. So you can write L by C, or you can write Cl by CD, but it is not normal Cl, it is ClMd by CdMd. What is ClMd? It is CD naught by K. What is the CdMd? 2 times of CD naught. So what is the EMD? You can check. You can write 1 upon 2 root CD naught Ki. Na? Check this, you can do by your own also. So this is the final result. So today what we have seen the how to calculate thrust required, dependency of the thrust required. You have to draw by the diagram also. Now check where is the thrust required. Diagram also you can draw for this. Fine, here thrust required. So L by D. You can check this. So if you check the result, so TR thrust required will be minimum when 1 upon L by D will be maximum. So if you draw the plot, you can get that. Yes or no? Thrust required and L by D max. Then easily it is available. You can check. You can draw here by this way. This is what? This is the thrust required. Okay. And now suppose this is the velocity graph. Okay. Velocity in meter per second. So if you draw the thrust required versus velocity, so you have seen that this type of graph you may get. Yes or no? Like one spoon. Huh? Total drag you have seen. Total drag is nothing but thrust required. Yes or no? So total drag you have seen. This is the plot for total drag. Okay. So the minimum L by D you may get here at this point. This is the point where you will have L by D max. Okay. So this value will be minimum thrust TR. So like thrust required you have seen, dependency of thrust required to the weight of the aircraft that you have seen, drag polar equation you have seen here, all the explanation I have given whatever it was possible in shorter time of period. See, and this is the graphical representation of the minimum drag. Okay, conclusion also available here for the minimum drag and condition also, and again mathematical analytical way also we have for the minimum drag condition. And at the minimum drag condition, what are the parameters like lift coefficient CLMD, drag coefficient at minimum drag will be CDMD. Let me write, this is called CDMD, CDMD, CDMD. Okay, here it is written. Then velocity at minimum drag condition, it should be VMD. So VMD also you got it. Similarly, aerodynamic efficiency at minimum drag. So this all right. In previous class, we had seen that minimum drag condition, and we had calculated that velocity at minimum drag condition. All the parameters we had calculated. Although we had calculated aerodynamic efficiency, which is L by D, at minimum drag condition. Okay. Now this is the one basically topic where we have to discuss that L by D ratio at the other speed, not at minimum drag speed, it is some other speed. So that speed they will give to you. So let me write this. This is nothing but new topic, which is L by D ratio. Okay, L by D ratio at other speeds. Okay. So now here one thing I need to mention. Just say suppose suppose an airplane is flying flying at some multiple m of the minimum drag speed of the minimum drag speed. What is the minimum drag speed? Last class I had denoted by VMD. Okay. Now, so we'll go for the further calculation. What we have? We have the weight, and what is the weight formula? Which is nothing but lip for steady level flight, and it is nothing but half rho v square h into CL. And as we are considering weight is a constant parameter, it is not going to change. So what we have, basically we'll say that the lift coefficient at this speed, the lift coefficient at this speed, now we had mentioned it's a multiple of minimum drag speed. So multiple of minimum drag speed means m times vmd. Okay, is given by how you can write in this case. What we have, v square cl, that will be constant because density will be constant, s area will be constant because weight is constant, hence you can say that v square cl is equal to constant. So now two types of velocity you have. One is the vmd, so you can say v square cl is constant. Two condition you have taken. One, when velocity is what, vmd, then cl will be clmd. Another case you have taken when v is now multiples of vmd, then cl is what denoting by cl only. Now you just put this uh, assumptions here. So what you may get, vmd square clmd is equal to, because it is constant, then again you can write, instead of v you can write m times vmd square, and we have cl. Yes or no? That you can, simple mathematics you can perform here. Yes. Now what you may have, what will be the cl? You check the cl value. Cl is nothing but clmd divided by m square, because vmd square will be cancel out both sides. So now you got this one very important result, clmd divided by m. M is the multiple, okay, of vmd. So if any speed which is given multiple of vmd, then that time what will be the value of cl? This value will be clmd m square. Sorry, this is the m square. This is the m square. This is very important. Okay, you need to take care of it. Number one. Similarly, we need to calculate cd also. So what will be the corresponding drag coefficient? Corresponding drag coefficient cd you need to calculate. What is the cd? cd as per drag polar, you know, cd is nothing but cd naught plus kcl square. This is what drag polar, already we had discussed in last to last class, right? So this is what cd naught, and for minimum drag, what is the kcl square? Kcl square is nothing but, it is induced drag which is also equal to Ct naught, but now we are considering this KCl square for multiple of m multiple of minimum drag speed. Hence we can write K as it is, and Cl just now you have calculated. What is the Cl? Here you have calculated CLMD by m square term you may get. So this is nothing but CD naught plus KCl MD square divided by m to power 4. This will be CD naught plus 1 m power 4. This is for minimum drag condition. CD naught plus, what is this KCLMD square? It is nothing but CD naught, minimum drag condition. So here you have CD naught in bracket 1 plus power 4. So what is the CD? CD naught in bracket 1 plus, this is very important. Just like a previous you have calculated CL value when speed becomes multiple of minimum drag speed, then CL you have calculated previously, and this is the CD value. Okay. Now here you are going to calculate L by D value for the speed which is multiple of minimum drag speed, m multiple of minimum drag speed. Now if you want to calculate the lip drag ratio L by D, so what will be L by D? What will be the L by D ratio? Okay, so now you perform here the calculation, simple calculation. What is the L by D? L by D is nothing but, as usual, L by D for steady level you can write CL by CD. There should not be any doubt. At constant speed, or not constant speed, at the same altitude, L by D will be CL by, because density should not change. Okay, then it will be CL by D will be directly replaced by CL by CD. Alright, what is the CL you have calculated? CLMD by m square. Check CL value, CLMD by m square. What is the CD? Just now you have calculated. It is nothing but CD naught. It is nothing but CD naught in bracket 1 plus m to power 4. Alright. Now this one also you can write CLMD m square. Here you can write CD naught 1 plus m to power 4 divided by m to power 4, or what you can write, what value you can write here? Simple, you can replace this value with the help of this simple calculation. You can write this CLMD by CD naught. Okay, and here what you may get, it's basically m power 4 by m square divided by 1 plus m power 4. Okay, this is what L by D. Now what you may get, L by D is equal to what I have written, CLMD by CD naught. Here it is nothing but m power 4 by m power 2, so it is nothing but m power 2 divided by 1 plus m power 4. Now you do one thing, you multiply it and divide by 2. What you may get, it is nothing but 2m square CLMD, okay, divide by 1 plus m to power 4, I can write like this, divide by 2 CD naught. L by D is equal to 2 m square divided by 1 plus m to power 4. What is this CLMD by CD? 2 CD naught, CLMD is nothing but L, you can write, and 2 CD naught, this is nothing but drag. Or one more step I should write CLMD, and this is 2 CD MD, okay. So this is nothing but 2 m square 1 plus m power 4, this is L by D max. Check my previous lecture, you may get it. So what is L by D? By L by D max, it is nothing but 2m square divided by 1 plus m to power 4. It's very important, very important. L by D they will give to you, or they will ask to you. L by D max they will be given to you. If you know the m value, anyhow, automatically you can calculate this value, okay. What is L by D? It is L by D max 2m square 1 plus m to power 4, where what is m? Actually v is equal to, v is replaced by m times of vmd. So what is m? M is nothing but v upon vmd, yes or no? So this formula is very important, very important, okay. Make star marks here. And what is the value of m? That should be aware, this is the m. All right, fine.